Hello everybody, this is Mr. Bowman. So today we're going to be looking at writing and solving equations. So we're getting a little bit away from those expressions. We're going to start adding those equal signs in, which makes them equations. And we are going to learn how to solve those things. So starting off, we're going to start similar to where we ended expressions. We're going to take a phrase and we're going to turn it into, in this case, an equation. So start off just like we did before. So Julio has $5 more than Dan. Together, Julio and Dan have $19. How much money does each young man have? All right, for the time being, I only want to use one variable if I can help it. So how much money does Julio have? And how much does Dan have? I have to pick one of them to be my variable. So I'm going to go ahead and pick D for Dan. So I'm going to say D is the amount of money that Dan has. And sometimes it'll tell you in the problem which one to use. Sometimes it won't. You'll have to pick. But usually it's pretty obvious which two things usually you're going between. You just had to pick one. So in this case, Dan or Julio. All right, so if I say D is the amount of money Dan has, how much does Julio have? So looking at our first sentence here, Julio has $5 more than Dan does. So if I want to know the amount Julio has, it's going to be D plus 5. Whatever Dan has, plus 5 more on top of that. And that is the amount of money that Julio has. Okay. All right, now that I have that, I can actually start putting those together. And in a lot of our expression ones, they gave you a variable automatically. They said something like the product of 6 and D or something like that. That may happen with equations as well. This is one of the trickier ones, so we had to pick our own variables. So just note, that's not entirely going away. So I have my two amounts, the amount Dan has, the amount Julio has. So the question is, how do I put these things together? So I need to find something that combines them, and that's my second sentence in this one. Altogether, Julio and Dan have $19. So when it says altogether, we have to figure out what operation is that. Is that addition, subtraction, multiplication, division, etc.? In this case, altogether means addition. So I'm going to have D for Dan's money plus D plus 5 for Julio's money, and altogether they have $19. So it's going to be equal to 19, and that's where this changes a little bit. If you have an expression, that means no equal signs. If you have an equation, you have to have an equal sign somewhere. So if I add these together, it comes out to equal 19. Okay. And then usually you're going to try and solve these, which is why writing and solving goes together so well. Sometimes you'll just have to solve it, and it'll be a little bit easier. So solving this one, I'm going to ignore the equals 19 for a second and just focus on my left side and say, what can I do to clean up that side? Because there's nothing I can do to clean up the right side. There's only one number. So over here, just like when we had expressions, I can combine my like terms and say D plus D is 2D. And then I can't do anything with the 5 because there's no other constants. Equals 19. Now's where things change a little bit. If I want to solve an equation, I need to get the variable by itself. All right? So right now, I have 2D plus 5. That's a problem because I need D, the only thing on that side. So I'm going to take a vertical line, draw it through my equal sign, so I can keep track of the left and right side of my equations really easily. So anytime I get an equal sign, it's going to be drawn on that line. So left side right now is 2D plus 5. Right side's 19. All right. So in order to get that D by itself, I need to start getting rid of the other things on that side. So I'm going to do that by doing what's known as an inverse operation, or undoing the math. So normally when we do a simplification, we use our order of operations, right? Parenthesis, exponents, multiplication, division in the same step, and addition and subtraction in the same step, going from left to right. So it's PEMDAS. That's the order of operations. If you're trying to solve, you do this process backwards. You're going to start it with addition and subtraction, then multiplication, division, deal with exponents, and in the off chance you have parentheses, you'll do that at the end. Okay. So I need to undo these in the opposite order, so it takes a little bit of getting used to. So looking here, I have a multiplication with 2d and an addition with 5. I need to undo the addition first. So I need to think, what's the opposite of adding 5? And that's subtracting 5. So I'm going to subtract 5 from both sides, making sure I line it up with like terms. And the reason I want to do that is 5 minus 5 is 0. Okay, which means this doesn't mean anything because I don't need to add 0 because it won't change. So the only thing I'm really left with on that left side is 2d, and then I put my equal sign back there because 2d plus 0 is just 2d. And then on this side, I have 19 minus 5, which is 14. Okay. Then I dealt with my addition and subtraction. I need to come back here and say, all right, this is multiplication. What's the opposite of multiplication? Division. So instead of multiplying by 2, which is what I'm doing, I'm going to divide both sides by 2. And it's always both sides so we can keep that whole thing equal. So 2 divided by 2 is 1, which cancels out, so I lose that, and it's just d. 14 over 2 is 7. Okay. Now be careful, this did start as a word problem. So what does that mean? Because I want to know how much money does each young man have. D, if I come back to where I took my notes, is the amount of money that Dan has. So Dan has $7. And then D plus 5 was Julio. So Julio has 7 plus 5, or $12. And that's where this one would wrap up. Okay. So I'm going to run through a few more of solving because it does take a little bit of practice. All right. So we're going to skip the writing portion because you guys have some practice with that from the expressions. So we're just going to practice that solving. So what if we have something like 3x minus 1, it's going to be very similar, equals 14. Okay. So remember, we're doing that order of operations backwards, so I need to undo my addition subtraction first. But I do like my line here, so I'm going to draw my line down. So do I have any addition and subtraction on the side that has the variable? I do. I got a subtraction right there. So I'm going to undo subtracting 1, which I do by adding 1. I'm going to do that to both sides. Okay. That adds up to 0, so it's unnecessary. So I'm just going to bring down the 3x, because this part doesn't matter, because it adds up to 1. 14 plus 1 is 15. And then last but not least, I need to divide both sides by 3, because I was multiplying by 3. So I want to do the opposite. Same number, opposite operation. This is gone. So I have x equals, and I didn't quite make a line long enough, but still there. 15 over 3 is 5. And since this wasn't a word problem, that's where you stop. Okay. All right. Now, what if there is a variable, more than one variable to deal with? So there's two situations where this happens. The first one is very similar to here. So that's if they're both on the same side. They're either both on the right or they're both on the left. So what if we have something like 10 equals 2x plus 5 plus 3x, or something like that. So I have two x's right now, and they're both on the right side. Right? There's my line. So both the 2x and the 3x are on the right side of my equation. In that case, we're just going to add our like terms together and go about it like normal. So there's nothing to do with on the left side with a 10. 2x plus 3x is 5x. And this is 5 there is not a like term because there is no variable with it. So it's the only constant on that right side, so it's done. After that first step, we now have more or less the same situation we had on our first example on this page. So I just need to cancel out my addition and subtractions. So I'm going to cancel my addition by subtracting 5. 10 minus 5 is 5 equals, this is gone. So I bring down the 5x. then I want to cancel out my multiplication by dividing. So in this case, this is gone. This also looks like it goes away, but remember what happens when we're dividing. So what is 5 divided by 5? It's 1. I didn't have to write it over here because 1 times x is the same as x, but there's nothing else on that left side, so I need to make sure I write down the 1. Okay. And then last but not least, our trickier scenarios, what happens when we have variables on both sides of the equation? What if I have something like 3x minus 1 equals 5x? Let's make sure this one comes out decently nicely. Let's go with plus 7. Okay. All right. In this case, your first step needs to be get all the variables onto the same side. We need to fix that fact that they're split right now. Okay. So you can do this in either way. My preference is to try to end with a positive number, just so I don't have to worry about dropping negative signs, but it really doesn't matter. So I need to cancel out one of these so they're on the same side. So my preference in this one is I'm going to subtract 3x minus 3x, once again putting under those like terms. Because this is now 0, and I don't need it, so I have negative 1 equals 5 minus 3 is 2x plus 7. And then it's very similar, once again, to the ones we've been doing. So anytime we have those weird scenarios, it's basically one new step. So let's finish this up quickly. So minus 7, because I want to cancel out adding 7. That's gone. Negative 1 minus 7 is negative 8. Divide by 2, and I end up with negative 4 equals x.